Apparently, some of you are having difficulty using your calculator because your screen looks different from the one that's on the video. So I'm going to walk through an example of a one mean Z test for hypothesis testing and show you how to use a screen that looks similar to the one that you have. And so I pulled this question from the practice problems, and it says, suppose that a recent article stated that the mean time spent in jail by first-time convicted burglar is 2.5 years. A study was then done to see if the mean time has increased in the new century. A random sample of 26 first-time convicted burglars in a recent year was selected. The mean length of time in jail from the survey was 3 years with a standard deviation of 1.8 years. Suppose that it is somehow known that the population standard deviation is 1.5 years. Conduct a hypothesis test to determine if the mean length of jail time has increased at the 0.10 level of significance. Assume the distribution of the jail times is approximately normal. Okay, so the first step in a hypothesis test, after you read through the problem carefully, is to identify your hypotheses and then state those hypotheses. So if you look near the end of the problem, about the next to the last sentence, it reads, conduct a hypothesis test to determine if the length of time of jail time has increased at the 0.10 level of significance. Okay, so and the word increased makes me think of the mass symbol greater than, and you may think, well, increased from what? Well, if you go back to the beginning of the problem, it tells us that the mean length of jail time is 2.5 years. Okay, so from that, I'm able to determine my null hypothesis, which is represented by H sub 0, and my alternative hypothesis of H sub A. Again, this word increased makes me think of the symbol greater than. It does not include equal, so that gives me the alternative hypothesis. So we would say the mean is greater than 2.5 years. Then, and I'm going to mark this OC as the original claim, because that's the one that's given in the problem. Then I have the mean is less than or equal to 2.5. Remember, the null hypothesis and the alternative hypothesis are exact opposites of each other. In the second step of the hypothesis test, we need to identify all the pieces of information that we need in order to work the problem. And if I'm thinking about using my calculator, then I need to identify mu. Whoops, sorry about that. It's jumping around on me. I need to identify mu. Whoops. Sorry about that. Mu sub 0, okay, which is the population mean. Okay, in this case, it is a value of 2.5. That value comes from the hypothesis. You also need the population standard deviation, which is sigma. Okay, now here's where you got to be really careful in this problem, because when you go back and you look through this problem, you may think, well, I've got 2 standard deviations. And you do. You have the standard deviation for the sample where they tested those 26 first-time burglars, but then it also clearly says the population standard deviation is 1.5. Okay, so if you have the population standard deviation, you need to use it. Okay, so the population standard deviation is 1.5, and that is given to you in the problem. And if you have the population standard deviation, you need to use it. We also need to identify X bar. I'm going to have to scroll down just a little bit. Okay, you have to identify X bar, which is your sample mean. Our sample mean, if we read through this again, it talks about sampling the 26 people, and it's found that the mean time of the survey, mean length of time in jail was 3 years. Okay, so X bar is 3, and that's given. And then lastly, one of the last things you need is N, which is your sample size, and we sampled 26 first-time convicted burglars, and so that was given. The last piece that's on your calculator screen, it says mu, and then it has 3 options: not equal to mu sub 0, less than mu sub 0, and then greater than mu sub 0. They're asking you to select whether you have a one-tailed test, a two-tailed test, and whether it's left tail or right tail. Because if you were doing these calculations by hand, that would affect the calculations. So we have to choose which one we have, and it's based on what symbol you have in the alternative hypothesis. And for us, the symbol in the alternative hypothesis is the greater than symbol. So I would select that one, and I'll show you how to do that on your calculator. And then you calculate. Okay, so we've identified everything from the problem. So I'm going to pull up the calculator. Okay, let me clear this out so you'll know how to get to it. Okay, so you go to Stat, press the Stat button, arrow to the right, highlighting the options for test. We're conducting a z-test, which is number 1. Here's one of the important things. You want to make sure that this word stats is highlighted. If it's not, you can arrow to the right, highlight it, and press enter. Okay, mine is already selected. And then I'm going to begin to enter the data onto my calculator, from my calculator. So my population mean was 2.5. My population standard deviation was 1.5. My sample mean is 3. My sample size was 26. Then I want to select which one I'm doing, and I'm doing a greater than. Okay, so notice that I arrowed to the right where I have the blinking light. I'm going to press enter. That selects it for me. Then I'm going to scroll down and highlight the word draw, hit enter, and it's going to draw the normal distribution, show you the shaded region, and give you your z-score. Okay, so underneath it gives me my z-test statistic as 1.6997, and it gives me my p-value of 0.0446. Okay, so I'm going to write those things down. Okay, so I have z equals 1.6997. Normally we round z's to 2 decimal places, so be careful. Let me review this with you. Okay, the second decimal place is a 9. Next door is a 9. So the 9 is going to bump the 9, so this rounds up to 1.70. Okay, well, that would be my decimal approximation. The corresponding p-value from my calculator is 0.0446. I then need to compare that p-value to the level of significance. The level of significance was given in the problem, okay, as 0.10. So we want to compare the p-value to alpha, which was given as 0.10, and my p-value is 0.0444. Now, a lot of students have trouble when they're doing this comparison, so let me kind of walk you through that as well. You compare it digit for digit, guys. So if I compare the 0 to the 1, 0 is less than 1. So the p-value is less than alpha or equal. So it's less than or equal. And the guideline says if it's less than or equal, if p is less than or equal to alpha, then we reject the null. Okay, so we're saying that our null hypothesis is false, which means based on the data we have, our alternative is true. And so then we write the final conclusion. Let me see if I can scroll down and write the final conclusion. We would say at the 0.10 level of significance, the mean length of time in jail for first time convicted burglars has increased from 2.5 years. And guys, when you're stating that conclusion, you want to add in as many details as possible. Okay, the more details you put in, it gives it the context and it makes it easier for someone to understand. So I hope this little quick short video helps you understand how to put the stuff into your calculator.